Yeah, thank you. Yeah, I also am a maintainer of some open source projects, but we don't use any of them, unfortunately. Yeah, and I'm going to talk today about automation tests at Babylon. You heard a little bit about kind of the same issues, kind of same stuff from Moonpig. So it will be, you actually will see some of very similar slides, but at the same time it will be a bit different view on the same problem, and it will be more about our own experience. So what we will talk about today. First of all, what issues do we face in our UI tests? Yeah, and I'm not going to talk about all automation process, our CI pipeline releases, only about UI tests. How do we solve these issues, or how we plan to solve them, because some of them we didn't solve yet. I'll show briefly how we actually write UI tests, how do they look like, and explain why they are BDD tests. Some of the tools that we use, and if we have time, maybe a short demo of some interesting things. What we will not talk about is why, how, and what you should test, because it's a completely different story. Deserves separate discussion, and I'm not here to teach you what you need to test. It all depends on your use cases. We'll talk more about what worked for us, what problems we had to solve, and what worked well and what worked not very well. So let's start with the issues we had. Probably everyone knows how this, like in 2018, everyone knows how to write UI tests, right? We actually don't even sometimes need to write UI tests because Xcode can write it for us. Of course, the result will be far from ideal, and that's probably not what you should leave in your production tests code base. But still, the point is that it's not very hard to write a code that will press a button on the screen. The problem start to appear when you write more and more such tests, when you scale. So what issues we encountered? Basically, they can be summed up as like unexpected failures, performance issues, and sometimes complexity of scenarios we have to test. It's either hard to manually test, or it's hard to automate, or even both. So one of the reasons of unexpected failures that I mentioned are changes in the content that we don't own. And the best example of this is part of our app, which is a chatbot. So basically how it works is that when you open the app, you can go into chat and you can ask whatever question you want, like, I have a stomachache. And our AI chatbot tries to understand what is your problem, and it can ask you some questions to try to understand better what's going on with you and to give you better results. Sometimes it can be like multiple choice questions. Sometimes it's just yes, no. Sometimes it's free form questions where you just type the answer. And these flows are controlled by the backend, by AI service. We don't know anything about what chatbot will ask us in the next question. And sometimes this flow change. And then our tests, they start to break because, for example, instead of receiving a question with two options, like okay and not now, let's say, we receive like sure and not now. And then our test failed because it cannot find the expected button with the text okay. So how we could probably solve it, and it would probably solve some of the cases, is that we could use some kind of unique identifier of these answers that chatbot provides us as options, and then use them as accessibility identifiers and then we will not depend on these copy changes. But we don't know what other kind of changes can happen. For example, the chatbot can give us the same answers, but the questions will be in a different order. So and we don't have control over it, and for application, it's completely opaque. So in these cases, we either have to come up with some very complicated thing that can answer whatever questions chatbot sends to us, or solve it in some other way. The best solution would be, of course, don't run such tests, but we have to. Actually, the best way to optimize stuff is doing less. Another problem is external system actions. So, for example, one of the main features of our app is that when you can have an appointment with a doctor. So, to have appointment with a doctor, it's not just you need to do something on the app. There are some actions required on external system that we call a GP portal, where GP logs in, press some buttons, starts appointment, and then application responds on these actions. So, for example, when you complete appointment, it actually doesn't complete when you hang up, when you complete the call. It's like Uber Drive. Uber driver, he completes the drive. So only when GP presses the button complete the appointment, only then application receives some push notifications, for example, that you have a new prescription, or please rate the appointment. So without this interaction in kind of third parties for our client, third party system, some things don't happen. Or another example is when in the chat you can select to ask question to clinician. Like, I don't want to talk to a machine. I want to talk with the answer from a real person. So this is like asynchronous communication. So there is a backlog of questions, and when GP comes to the question, they answer it, and then application receives push notification and reacts to it. So without this external interaction, nothing will happen. And in this case, these kind of scenarios, they are hard to test manually because you need to switch from application to the GP portal. You need to do a lot of stuff just to test, for example, that user can start a call or receive a prescription notification. But at the same time, they're also kind of hard to automate. Another problem is network stability. This is very common. And it's not just about how good is your Wi-Fi signal in the room with your test device. It's about everything that can happen between application and your server, like 500s, timeouts, connection drops, and so on. And if your tests are running in the cloud, like our tests, we are not running them. Well, we used to run them on our own machine in our office, but now we are running everything in the cloud, so we have no control over environment. So in this setup, your test can become even more flaky because of network stability. And some guys, like on this picture, they even build racks of test devices with cameras and separate Wi-Fi signals. So this is actually how you probably saw this on TechCrunch. It's a test rack made by Facebook. So each rack has like 30,000 of devices, and each rack has their own Wi-Fi signal. And to avoid network problems between different racks, so that these network signals don't collide with each other, they have to make electromagnetic enclosures. So people face different issues with network. We don't have these problems, thanks God. So the network stability brings us to another problem, which is performance. Because network can also affect the performance of your test. But it's not just about that. It's not just about device performance or simulator performance. We just can't control, even if you have MacBook Pro. It's mostly about repeated test steps, what guys in Moonpig also have to solve. So for example, each of our automation tests needs to start with a fresh state because we want them to be independent and isolated. So we need to start tests with registering new user. Then if we test appointment, then we go to appointment tab, then we enter our symptom. You saw the screen in Anders' presentation. You enter your symptoms, then you tap on book appointment, you add a payment method, which is very slow operation. Then you confirm your payment and tada, you have appointment. And then in next test that tests something else related to appointment feature, you basically have to repeat these sections again. And this is eating a lot of time. So this leads to a lot of steps being repeated and performed over and over again. And then we face a dilemma. Like either we can have a large test with multiple assertions, which is kind of meh. But in the end, we will have faster test suite because we have less steps repeated over and over again. Or we can have more focused tests, which is a better thing from like testing perspective, because you have better focus on what's going on and why things fail and so on. But in the end, you have a slower test suite because every test have to do the same preparation. So these are basically the main, like the top of the iceberg, I would say, problems that we have to deal with. Of course, it's not all of it. The main problem is that developers break our automation test. Yeah, but that's the problem of the process, not the tool. So how do we solve these issues? Or how do we plan to solve them? Basically, our strategy is control the world. So there are two parts of the world. There is a network. Basically, it's everything outside of the app, and there is our inside world. It's what inside the app, and basically there we just need to manage initial state of the application because in runtime test already control the runtime test of the application. So we just need to care about initial state. So what does it mean to control the network? It means that the test, instead of some backend service or mock client in the cloud, has a full control over what data application receives or errors that application receives. So how we can do this? This is actually very trivial when you write unit tests, because in unit tests you are running in the same process as your test as the code that you test. So you have access to the same network stack that your code is using. So you can use dependency injection to inject the mock instead of real URL session, or you can use URL protocol, like one of the most popular approaches, to serve stub data. Or you can completely replace network stack with some stub. But when it comes to UI tests, you don't have this because UI tests is running in a separate process than your application. There is a separate process of a test runner with its own network stack. So it's kind of trickier to control the network stack of the app and influence the app from UI tests. But there are ways. And what are these ways? So basically there are two options. You can do it from inside the app, or you can do it from inside the test runner. When you're doing it from the inside the app, that it's basically the same way as you would do it in UI tests. You have this network, you have these stubs. Again, the most popular approach is probably, well, I don't know what is more popular, dependency injection or URL protocol, but I think URL protocols are most, they require you less changes in your legacy code, let's say. So basically the idea is that you register a custom URL protocol that intercepts all the HTTP requests, and then it can return you JSON stubs instead of making a real request. And here's, for example, a piece of code from, I think it's Mockingjay. So basically every time when there is a request to some kind of endpoint, described by this URL, it will return your stub data. What do you need to do to implement this approach? First, you need to integrate this code in the app. Like, okay, it can be different targets, like a special test, doubles target or whatever, but anyway, you need to make the app use this somehow. And the problem is not that your app will be aware that, yeah, it's running in UI test, there is some compilation condition that uses this instead of using real URL session. The problem is that how much code you will need to write for that and how well isolated from the app it will be. Because in my opinion, like having test-related code so closely integrated with the app is like not a good thing. And even if you manage to isolate it, it's possible. It's actually not very hard to do. If you manage to isolate it, you still have different, you have your basically test data you have in different targets. Just test it, your test is in one target and your test data is in another target. So you need to juggle and jump from one target to another. And then the other problem is that the other thing that you need to do is you need to instruct the app what stubs to use. For example, you saw in the previous presentation that guys are just passing the some response in a lunch arguments. Yeah, that's the most common approach. The problem is that it's not very flexible. You will probably not pass the whole network session recording scenario like with a 100 requests through lunch arguments. I'm not even sure that it will fit. So it works, but it has some limitations, and it's when it comes to flexibility, I think it's not very flexible. So in sum up, it's a straightforward way to do things. It's a good thing. The problem is that you need to integrate it in your application code, and then it's not very flexible. Though maybe the only thing that you need is to just pass a test name through the launch argument, and then the application will pick up all the JSON files in the tests in the folder with the same test name, and then it works perfectly. That's actually kind of similar thing that what we do. And then there is another option from inside the test runner, and that's what we actually start to use. And the main thing here is a local web server. So instead, with this approach, instead of making requests to real backend service, you make requests to a local web server that actually runs on the same machine as your tests. Well, in our case, we run all the tests in simulator, so it just starts on the local host, and the application just goes to the local host instead of real backend. I guess you can do the same on the device too, though we didn't try. And then when the application makes a request to a local host, the code that handles this request is actually part of your test. And then it can decide what to do with this request. Return some step data, return error, or just proxy it to the real server and just log somewhere. And possibilities are endless. And there are multiple scenarios how you can use it, which we will discuss later. You can log your network calls just for debugging purposes, because it gives you very useful insight why tests might fail. You can use these logs as snapshots to run your tests later against this snapshot instead of running against real network. Or you can even implement complete mock of your backend and never reach the real service. Of course, this approach requires some integration. On higher level, in the test, what you need to do is basically you start the server and then you configure something that will intercept your request. I'll talk about in details about this a bit later. Of course, you will need to integrate some code to work with this in the app, but most likely you already have everything that you need. And anyway, it will be much better isolated from the app code, and everything will be in one target, close to the test. So what do you need to do to use local web server in the app? So basically, the main thing is that you need to be able to switch environment. So if your application already supports several environments, like development, staging, production, then basically you don't need to do anything. You just need to add local environment that will replace the host of your API. In our case, we had to do a bit more job because like we have multiple backend services which are deployed to different hosts. So we have like API base, API 1 base URL, API 2 base URL. So when we intercept this request, we need to understand to what exact service this request was made. So we can't just replace the host. So instead, we just put this host. As you can see, we put it in the path as a first path component of the URL, and the host will be a local host. So basically, this thing is just a very lightweight wrapper around other environments that we use in the app, like dev, staging, production, pre-production. And then we integrate it with the same machinery that the way we switch the environments in the app. And another thing, which is very small, is that to talk with the local host, you need to, and if you use a TSL, Transport Security Layer, then you need to enable it, local networking in FOP-list. Basically, we do it with the one script in our build phase, which we do just for debug. I couldn't find information if it's not good to do it in production app, but you basically just don't need it in production unless you do some Internet of Things, like devices with Bluetooth. And that's basically it. You don't need to do anything else in the app. For the app, the fact that it's talking to local web server instead of real server is irrelevant. It doesn't know about it. On the test side, you need to do a bit more. So first of all, you of course need this implementation of web server, but of course you don't need to write it from scratch. Though if you want, you can. There are already multiple solutions, open source solutions, which were there for quite some time, like GCD web server. It's even written in Objective-C, Swifter, even Kitura. You can run it on iOS, though instructions are very complicated and I couldn't make it run. Or if you fancy, you can implement your own with Swift and IO because it supports iOS. In our case, we use a small, very tiny implementation called Ambassador. It's relatively unknown, but it works pretty well, and it doesn't have what we don't need, like HTML or other stuff. So we just do one thing and does it. And it basically doesn't even matter what particular implementation you use. What matters is the approach. And these implementations, they kind of work the same way. And the second thing that you will need to do is you need to intercept your requests. So note this line here. So there is a server router, and then it assigns some intercept response thing. So now we will see what is this. So basically, how all web frameworks approach handling incoming requests is through router. Router is kind of a map, on a high level, it's a mapping between URL with the query parameters, path parameters, and some functions that will handle them and return some result. So basically, all these Ambassador GCD web server, they're built this way, more or less. And basically, as you saw, you just need to write one line of code, one line of code to implement this. And we use this handler, which we call intercept response. Of course, it's not a real implementation. It's just to show the idea of what it's doing. So basically, what it does, it receives incoming requests with all the data about it in an environment variable, environment parameter. Then it parses these environment parameters. It will contain like path, host, method, body, query parameters, and so on. Then it builds on top of that request to a real server, and then it uses just a regular URL session to make a request to a real server, and then it sends the result back. So basically what it does is just proxies the request. But this piece of code actually gives us a lot of possibilities in future. And when we have this, we can do whatever we want. But let's talk first about some edge cases that we found working on this approach. So first thing is parallel testing. So you maybe know Xcode 10 allows to run tests in parallel. So this is kind of a problem for this approach because when you start a local web server, it listens to some port. So when you have started one server on port 80, you can start another server on the same port. So your another test has to start server on another port. So basically, the problem is trivial to solve. We just increment port until we find one empty port where we can start a server, and we just proceed. Another problem is that sometimes our backend returns us absolute URLs in responses to some resources, for example, images. And if we want to intercept these responses, these requests too, and not just let application go silently to the backend, we need to change these URLs in request. And here we had a problem because sometimes we get these URLs not just as a property in JSON, but we get it as a part of another URL as a query parameter. And it can contain, for example, URL to NHS host. And then when we were just replacing HTTP with HTTP localhost, we started to get, our application started to make requests to HTTP localhost NHS blah, 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 which of course failed. So here we had to be more careful, and now we only replace URLs to our own host and allow all other requests go through without intercepting them. And another problem is overriding response size, which is directly related to the previous problem, because when you start to manipulate a response, you need to change some headers that describe the size of this response, because application will try to use these headers to understand how much data it needs to read from the network, and if it doesn't sum up, then it can fail request or read just a partial data. So basically we had to solve this too, but with Ambassador it was actually very trivial. There are maybe some other edge cases that we just didn't encounter yet. So now let's talk about how we use this thing. So the simplest use case is just logging. So with this, we can, during development, we have all the logs of all the network requests and interactions with the app in one log, instead of having interactions with the app from the test in one log and network logs in a regular application logs, and then in Xcode you need to switch these two things in the debugger menu, which is very annoying. So now we can easily see everything what is happening in our test in one log. And this gives us very useful insights if something is going wrong. We also use the same logs to create snapshots. And this is similar to snapshots for UI components. Just instead of recording image, it records JSON, records text data. So each test can run the same as snapshot test. It can run in either record or replay mode. In record mode, it reads, it saves all these responses to the file, and in replay mode, it just reads them and matches them by some algorithm. And another pretty rare use case for us is that sometimes we fully mock the backend. So the test it actually cannot even work against real backend. So it relies on a local server implementing all the endpoints that this particular test needs to execute. But it's a pretty rare case. Let's talk a bit more about network session recordings. So this is actually was very trivial to do because how we implemented this proxying. So first my attempt was instead of making own URL session request, just return 302 or 303, some redirect status code, and then application network stack it understands where it needs to redirect and just redirect. But then we lose the ability to intercept the response and see what actually this request returned. And instead, we started to use this URL session data tasks. And because of that, we can use the same techniques that some people use in unit tests for recording. It's just dependency injection. So instead of using real URL session in record mode, we use session mock that not just makes a request, but also records everything, request and response into files. And for that, there are also some open source solutions. One of which is DVR. It's like directly related to Ruby solution called VCR or something like that. We are using a different one, which actually our team members wrote, called Vinyl, and it actually worked much better than DVR. Much easier to use and actually works better. Yeah. Yeah, contributor of Vinyl. So basically there are three things that we need to do to set up this recording. First, we need to detect the recording mode that we are running in, either it's recording or replay. Then we configure a matching strategy. This I will explain a bit like on the next slide, what is a matching strategy. And then we create this URL mock, which is called turntable, that handles all this heavy lifting of writing into files. And then we just pass it through dependency injection into session parameter and constructor of this response interceptor. So now how this matching works. Yeah, so basically what we do is that we use this matching strategy that matches everything in the request. It matches, well, except headers. It matches method, it matches URL, it matches query, it matches body. And then there is this parameter play tracks uniquely, which I don't remember what it is, but it's important. The problem with this matching strategy is this part body. Why it's a problem? Because as I mentioned, each of our tests starts from clean state, so we have to register user. So to register user, we need some unique email because we cannot reuse emails that were already registered. And yeah, we are running against like not a production environment, but a real environment. So we are generating as an input for login form, we are generating random strings that we are entering through UI tests. But that means that when you recorded this test once, it will record the part, these credentials, these random credentials that we used, it will record it in the file as a part of request body. And then when it tries to replay, it will try to match the, in the next test where it uses different input because it's random, it will try to match the body and it will say, body doesn't match. Like, I don't know what, I don't have recording for this request. And then it fails. It says that this request was not recorded. So how we solved it, we just basically, next to the file with network recordings that Vinyl creates for us, we just write our own file with a JSON that represents this random data. Like we use some unique key to understand where this input was used, like registration email, and we just record it. And the method that generates these random strings in replay mode, instead of generating random string, it tries to read it from the file. Basically, it's like a second level of recording, but on our side, not on Vinyl. what's next? Another problem, interesting problem that we actually didn't solve yet because it's not kind of blocking us yet, but it will. And it's related to random input. It's a current date. So, for example, when we book appointment, we receive from the backend available slots for appointment, and this is represented as a time. But of course, the full representation is a date, and this date should be in the future because you can have appointment yesterday. So imagine the scenario when you record this test today and you try to replay this test against recording that was made yesterday, and you receive some time slots that are yesterday, and then our application says like this time slot expired, you can have appointment this time slot. So again, how we plan to solve it is that everywhere where we use date constructor, which creates current date, basically instead of that, we need to use some kind of custom factory that in tests, it will try to read the date of recording, that was made, when the network recording was made and return it as a current date. So basically all the tests will run at the single, moment, in the past. And in production, it will of course return current date. Another use case that I mentioned is mock backend. This is particularly useful for scenarios that I was talking before that require interaction not just with app but with a third-party system. For example, in testing prescription flow. For that, we need a prescription to be created on the backend. But we can't create prescription without having appointment and without having this interaction on a third party, on a GP portal. Or scenario that is registering with Facebook. Like every time when we register with Facebook, we basically will need to create a different test Facebook user because we already used it. And next time we can't use the same test user with the same credentials because we have already registered user with the same email. So we could probably create new test users, but it will be very slow and we will depend on Facebook infrastructure, which is not a good thing to do. So instead of that, we write complete mock of the backend that mocks every endpoint, for example, that application reaches during registration flow. And we can say, like, in this test scenario, server on registering with Facebook will return us an error. On this test scenario, it will return us success state. And like on high level, it's just this. The main problem with this approach is that you need to mock everything. And when you start to mock one endpoint, especially when it's very early in the life cycle of the app, for example, registering, or the one that returns you tokens, you need to mock everything because you have a token that real backend doesn't understand. So you can't anymore talk to real backend. So for that, you will need to write some kind of boilerplate code just to implement all these endpoints. But actually, like on this example, it can look pretty straightforward. And actually, last 2 days, I was writing some new UI tests, and I was using this thing to implement like 5 new endpoints, and they all look the same. They look like patient, then there is some number which is a URL parameter, and then this get method will go to patient collection, will filter patient by ID from this URL path parameter. So this is a helper that you can write to make your life easier with this approach. And then in tests, we say that, okay, this test scenario will kind of pretend that this patient is registered. And for that, we don't even have to use JSONs. We can use the same data objects that we use in the app. The only thing that we need to implement is encodable. So in your app, you probably implement the codable part because you don't submit everything to the backend from the app. But on the mock server side, you need to implement another part, which is encodable, because you send this data as JSON. So this is kind of boilerplate that you need to write, but it can be solved pretty easily. So yeah, it requires some more work to do, and for this reason we are not using this approach extensively, also because we don't have a lot of scenarios for which we are writing tests right now which require this. So most likely we will move more to the direction of using recordings. Other problems that this approach solves out of the box, you don't even need to think about it, is network stability and content stability, because you just don't reach network. You read data from JSON and it's stable, no one changes it. And it's a bit different to what guys in Moonpig described with the mock server, where you have JSONs that everyone adds, kind of the same, but it's something like we don't try these JSONs manually. We just record it and we just store it. We don't even read them. So it's something that frameworks just uses as snapshots, the same way as you don't draw your snapshot reference images by hand. You just make an application to make a snapshot and just store it. So this all makes tests less flaky and probably even a bit faster, because you don't have these connectivity issues and you don't have to reach network. Let's talk next about another issue, test performance. Specifically repeating steps in different test cases. For example, when, as I explained, we have to register user every time, or in other cases, when we have a security check in the application. So every time when user access clinical records, we need to ask him for a password. We don't do it every time. We do it like iTunes, for example, every 15 minutes, or every 30 minutes when token expires, we ask for password. And because of that, if we don't do anything with that, every test that involves interaction with clinical records or in other parts of the app protected with this alert, it needs to handle this alert. And basically it's useless. But we need to spend sometimes significant time in tests just to detecting this alert, entering password, just to let us through. Instead of just having one test that checks, like, okay, when you tap on clinical records, we show this alert and everything works fine. And the other tests don't have to care about it. So how we solve it is that we introduce some shortcuts in the app that we pass through launch arguments, because it's the best way to change application behavior from UI test. So basically they behave like a special feature toggles. It's like a Boolean variables that application uses just when running in tests. For example, to solve this thing, we just pass the password that is constant for all our test users, and it just enters it. Instead of entering in UI, it just sends it as a result of entering password in this alert. Or for example, we override user defaults that we use in real app, for example, to detect that we already showed a notification alert, like the screen that asks user to enable notifications. Or we use it to make application use memory storage instead of keychain storage, so that it doesn't store authentication token in the keychain, so we don't have to clean it before the next test. And next test automatically starts from a fresh state. Before that, we actually were in an even worse scenario, like because we store token in a keychain, next time you start a test, you are logged in from the previous test. So that each test had to go to logout screen, scroll to logout button, press logout, and then log in. Now we don't have it. In other cases, when we have all these repeated steps, for example, to book appointment, instead what we can, or to register user, instead what we can do, and we actually already do it for authentication is that we can do from from test process, from the test itself, we can do some API calls, like for example, to register user. And then we use these credentials to enter them, what we're currently doing, to enter them in a login form. So basically how test starts is making a network API call to register user with some data, with some password and email, and then it receives a successful response, and then it starts the app, it goes to login form, it enters this password and email, and it is logged in, instead of filling all registration form, which is much longer. How we can even further improve it is that we can make the same API call, but instead of using username and password and actually entering them in login form, we can just use an authentication token, pass it through the launch arguments to the app. The application will store it in this memory storage, and then when we start it, it will think that I'm already logged in. So we cut even more time on the test. And we are planning to introduce this in our tests, and also we are working currently on splitting our application in more frameworks. So we probably will have opportunity to do even more stuff, for example, to make API calls to schedule appointment, or to add a family member. And then the test will concentrate on everything else. So yeah, enough about problems and solutions. Let's see let's see the code, how actually our UI tests look like. So this is actually example of, well, it's not the real test, it's the test that I use to test the local server. But it's basically the same thing that we do in each test. So you can see that in setup, it actually uses the mock server, and here it uses it in replay mode. Basically, that's the only thing that you can do. You need to do to use this local server in this scenario when you are just writing tests. You just need to change from replay to record mode. And then there is a test which is written basically in plain English. And this style is called BDD. And it describes not just what buttons we need to tap on the screen with a plain Swift code. It describes the whole acceptance criteria of this test. You can even call it like acceptance test. So it's much better documentation of requirements of your product, and it can be understood by anyone in your team, not just the developer who wrote it and work on this feature, but by product owner. Even product owner can write it. And you don't even have to use English, because it's just plain strings. You can write it in German. The only thing that will be in English is this DSL keywords, which are functions. So to write tests like this, we use the framework that you can see the import in the top. It's called test Gherkin. So Gherkin in German is Cucumber, and Cucumber is actually a popular test tool that uses Gherkin, which is a DSL that uses this given, when, then syntax, and it uses it to run tests. But it also used in such tools as Calabash, which probably you are more familiar with. And in fact, Cucumber already has their own Objective-C parser of this Gherkin syntax. And there are other implementations of this, like Cucumberish, but they are doing too much things that we actually need. We just need this DSL, and XCTest Gherkin provides us this DSL, and we're happy with it. So of course, these tests, if you just run it, it will compile, it will try to run, because it's a valid Swift code. But when you run it on the first given line, it will crash, because the framework will say, I don't know what you want. I don't know how to launch the app. So you need to tell application how to perform these steps. So for that, you basically use this functions step with some expression, which this expression is basically just a regular expression. And then what Gherkin framework does is that it has mapping between these regular expressions and these functions that you pass as a closure that implements this step. So in runtime, when you invoke the step, for example, I launch the app, the framework goes through all the steps that it knows about, and it tries to find the match, the regular expression matching. It tries to find the matching step, and when it finds it, it just implements this closure. So this way, we implement all our steps, high-level steps for tests. Basically, each step can do several assertions. For example, the second step, it checks that this screen is displayed, another screen is displayed, and then there is some tab bar item selected. And as you can see, we use here a page object pattern. So this tab bar menu and home screen, these are page objects. So this is a pattern that we use to abstract all implementation details of the screen under test, or part of the screen under test. So it abstracts all the interactions with the UI elements. And this makes our steps also very readable. So this is basically also some kind of DSL. There is no tapping on the buttons happening. So for example, here, the example of home screen, it has some accessibility identifiers, and then it has a method that returns bool if screen is displayed or not. And then it has all the details, implementation details of how to understand that screen is displayed. For example, here it uses, it checks the root view, and checks that its accessibility identifier is what it needs to be. So we use page objects. Another thing that we use is the step definers, which provide all the implementations of the steps and use page objects to actually do stuff. And then we use these steps in features, which are basically subclasses of XCTest. XCTest case. It's just a fancy name of naming it. Basically, it comes from Gherkin and from Cucumber, where you basically don't write code, you write feature files, which are just plain English, plain Gherkin scenarios. Another interesting feature of this XCTest Gherkin is that it uses XCTest activity. So every time when you implement step, it will create this activity with the same expression. So we will see all these steps that we performed exactly in the same way as they are displayed, as they are written in the test. We can see them in the test log. And as you can see, we use the same tool as guys from Moonpig use it. Actually, I learned that they recommended us through search. So we use this XCTest HTML reporter, which basically looks like an activity log in Xcode, except that you can easily view images, and you can see that all these steps, they are there, and there is no location in the code, but in the next, in a version, some latest update of Gherkin, XCTest Gherkin, they added the ability to see like the location in a Swift file where this step is implemented, so you can even use it for better navigation. And another thing that our local web server allows us to do is that we can see all the network logs here in this log, so we can attach them to these actions as attachments, activities as attachments. Or we can go to this second tab called logs, and we will see not just logs of UI actions, we will also see all the logs of network calls. So when test fails, we don't just see the screen and wonder why we see it. We can see why it actually happened, because some previous request returned us something that we didn't expect. So when these logs we attach to our CI jobs, and everyone can view them like they run this test locally. Well, that's basically it that I wanted to talk about. Do we have time for demo? Like a short? No, but anyway, I have it in my Twitter, the GIF. So here are some links for the tools that I mentioned, for the web server, snapshot tools, BDD tests, this XC test Gherkin and Cucumberish, and this HTML report. And yeah, that's it.